Hello, in this lecture we'll find out the length of line segment X. In the drawing we have two quarter circles. Those two quarter circles touch each other at point B. In addition, you know that AB equals to 1, QS equals to SP, and our mission is to find out the length of this line segment BC that is equal to X. So first of all, this is a quarter circle, and therefore AB equals to AP. They are both the radii of this quarter circle, therefore they are equal to each other. But AB equals to 1, therefore AP must be also equal to 1. Likewise, this is a quarter circle, and therefore BC and QC, they are both the radii of this quarter circle, therefore they are equal to each other. But BC equals to X, therefore BC equals to X, therefore QC must be also equal to X. In the next step, we join points P and B together by a straight line. And we join points Q and B together by a straight line. So I'll copy the right triangle PAB in the new page and we'll implement on this right triangle PAB the Pythagoras theorem. Okay. Here by P, T is abbreviation for Pythagoras theorem. Actually, this is the right triangle PAB, it's the copy from the original domain. Side PA equals to side AB, they are both equal to 1 unit, they are the radii of the quarter circle. So in this right triangle PAB, according to the Pythagoras theorem, PB square, that is the square of the hypotenuse, equals to PA square plus AB square. So PB square equals to PA square. PA is 1, therefore BA square is 1 squared, that is 1, plus AB square. AB is also 1, therefore AB square is 1 squared, that is 1. So in total BB square equals to 1 plus 1, that is 2. PB square equals to 2. We take a root out of this equation. And finally we get that PB equals to the square root of 2 units. Here, the hypotenuse PB of the right triangle PAB equals to the square root of 2 units in its length. Likewise, I'll copy the right triangle QBC in the new page and we'll implement the Pythagoras theorem on this right triangle QCB. Again, by PT is the version for Pythagoras theorem. So actually, this is the right triangle QCB that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle QCB, QB square, that is the square of the hypotenuse, equals to QC square plus BC square. So QB square equals to QC square. QC is x, therefore QC square is x square plus BC square. BC is x, therefore BC square is x square. So in total QB square equals to x square plus x square, that is 2x square. So QB square equals to 2x square. Here you take a look at this equation and we get that QB equals to the square root of 2 times x square. That is to say it is equals to the square root of 2 and the square root of x square is x. So in total QB equals to the square root of 2 times x. Units in its name. So when I go to the original drawing, that the hypotenuse QB of the right triangle QCB equals to the square root of 2 times x units. Okay. So in the right triangle PAB, side PA equals to side AB, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, we have those two angles that must be also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha because those two angles are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees, and it is also true in the triangle PAB. So which angles we have in the right triangle PAB? Inside the right triangle PAB, we have alpha plus alpha, that is 2 alpha, plus this angle, that is right angle that is equal to 90 degrees. So in total the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Repeat again. In the right triangle PAB, the sum of the angles must be equal to 180 degrees, that is to say 2 alpha plus 90 degrees equals to 180 degrees. We will subtract 90 degrees from this equation, and we get that 2 alpha equals to 180 degrees minus 90 degrees is 90 degrees. Here we divide this equation by 2, and finally we get that alpha equals to 90 degrees over 2, that is 45 degrees. So actually, this is angle alpha that is equal to 45 degrees in its size. And this is also angle alpha that is equal to 45 degrees. If we repeat on the same process on the right triangle QCB, we get that those two angles, each of them is also equal to 45 degrees. So this angle equals to 45 degrees, and this angle will be also equal to 45 degrees in its size. In the next step, I present to you rule number 3, and we will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have a straight line. This is a straight line AB. So if we focus on the upper side of this straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. According to this rule number 3. So which angles we have in the upper side of AB at point Q? We have this angle alpha and the other angle that is beta. So alpha plus beta must be equal to 180 degrees according to this rule number 3. So we actually can implement rule number 3 in our drawing. Why? Because in our drawing we have this is a straight line AC. So if we focus on the upper side of this straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I'll copy the straight line AC with point B in the new page, and we'll implement rule number 3 in this straight line AC. Actually, this is the straight line AC that I copied from the original drawing. So, at the upper side of this straight line AC at point B here, the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AC at point B? We have this angle that is 45 degrees, plus the missing angle that we will define as X, plus this angle that is 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So 45 degrees plus 45 degrees is 90 degrees. So in total, this side of the equation we have 90 degrees plus X is equal to 180 degrees. Here we subtract 90 degrees from this equation, and finally we get that the missing angle X equals to 180 degrees minus 90 degrees is 90 degrees. So the missing angle, this missing angle is the right angle, it is equal to 90 degrees in its size. So you can write down in the original drawing, this is the missing angle, it is equal to 90 degrees in its size. That is to say, it is a right angle. In the next step, I'll copy the right angle PBQ in the new page, and we will block this right angle PBQ by a circle. We have the rule that any triangle can be blocked by a circle, and especially it is true in the right angle PBQ. So actually, this is the right angle PBQ that I copied from the original drawing. Here, I block this right angle PBQ by this circle. So in the drawing, we have peripheral angle PBQ. This peripheral angle PBQ is equal to 90 degrees in its size, and we have rule number 5 that relates to any peripheral angle that is a right angle. So I write down that peripheral angle PBQ equals to 90 degrees in its size. Therefore, we can implement here rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must be subtended on the diameter of the circle. So this is peripheral angle MAN, that is a right angle. Therefore, according to this rule, all over 5, this peripheral angle must be subtended on the diameter of the circle. And it is very easy to see that MN, called MN, it is indeed the diameter of the circle. So in conclusion, you can say that any peripheral angle that is equal to 90 degrees in its size must be subtended on the diameter of the circle, exactly according what we can see here in the drawing, that peripheral angle MAN, that is a right angle, it is subtended on the diameter of the circle. So we can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle PBQ, that is a right angle, therefore this peripheral angle must be subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. So according to rule number 5, because of the fact that peripheral angle PPQ is a right angle, according to rule number 5, peripheral angle PPQ is subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. This is called PQ as the diameter of the circle. So if we define the radius of this circle as R, then the diameter PQ must be equal to 2R. Okay, so the diameter PQ equals to 2R on one side, but from the other side, it is given us the equation that PS equals to QS. PS equals to QS. So if PS is X, then QS must be also equal to X because they are equal to each other. So in total, the length of PQ is PS plus SQ. That is to say, PQ equals to PS, that is X, plus SQ, that is X. So in total, PQ equals to X plus X, that is 2X. So from the other side, PQ also equals to 2X. PQ equals to 2X. So PQ equals to R, it is the diameter of the circle, and it is also equals to 2X. So from those two equations, we will derive that 2R equals to 2X. R equals to 2X. So equals to 2X. Here we divide this equation by 2, and finally we get that R equals to X. So actually found out that X equals to R, and also X equals to R. So I can write down here that so here I will copy point S. Point S is located on PQ. So I'll copy point S from this original drawing to our new drawing here. Exactly where point S is located in PQ, I'll copy it on PQ here. So this is point S that I copied from the original drawing. Because point S is located on PQ, therefore I can copy point S from PQ exactly to the same location where it is located on PQ in the original drawing. This is point S that I copied from the original drawing, and we found out that PS equals to R. Here PS equals to R, it is the radius of this circle, and SQ also equals to R, it is also the radius of this circle. So PS is the radius of this circle. The radius PS starts from point P and ends at point S. And you have the radius QS that starts from point Q and ends at point S. So at point S, the two radii touch each other, and therefore point S is the center of the circle. Can I write down here that point S is the center of the circle, because the two radii touch each other at point S. Therefore point S is the radius of the circle. It is the center of the circle. Point S is the center of the circle. Again, point S is the center of the circle because at point S, the two radii touch each other. Okay. In the next step, we join points S and B together by a straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore line segment SB is the radius of this circle that is equal to R. In conclusion, we found out that QS equals to SP equals to SB, all the radii of this circle, therefore they are equal to each other. So here we join points S and B together by a straight line. SB is the radius of the previous circle, therefore it is equals to R. So if we found out that QS equals to SB equals to SP. In the next step, we'll do a construction. First of all, I will copy this big quarter circle to a new page, and then we will extend this quarter circle to a circle. So actually, this is the quarter circle that I got from the original drawing. Here, SQ equals to SB, they are both the radii of the previous circle, therefore they are equal to each other. So I completed the quarter circle to a circle. In the next step, I present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 13. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB equals to theta in its size, and it is subtended on RKB. In addition, we have in this drawing central angle AOB. This is central angle AOB that is also subtended on the same arc RKB. And therefore, according to this rule number 13, the peripheral angle AOB must be twice as large as the peripheral angle ACB that is subtended on the same arc RKB. So whenever you have a peripheral angle and the central angle in the circle that both of them are subtended on the same arc, the central angle will be always twice as large as the peripheral angle. Here we have peripheral angle ACB and peripheral angle AOB, they are subtended on the same arc RKB. Therefore, the peripheral angle ACB equals to theta, and therefore the central angle AOB equals to 2 theta. Why? Because both of them are subtended on the same arc RKB. We can actually implement rule number 13 in our drawing. Why? Because in our drawing we have, this is peripheral angle BSQ. Repeat again. This is peripheral angle BSQ, and this peripheral angle BSQ is subtended on RQB. Again, peripheral angle BSQ is subtended on RQB. And we also have the central angle QCB. This is the central angle QCB that is subtended on the same arc RQB. Therefore, the central angle QCB must be twice as large as the peripheral angle BSQ that is subtended on the same arc RQB. Now we must find out what is the size of the central angle QCB, and then the central angle, the size of the central angle over 2 will be the size of this peripheral angle BSQ according to rule number 13. We'll find out the size of the central angle QCB according to rule number 6. According to rule number 6, we have the sum of the angles around the point will always add up to 360 degrees. So in the drawing we have, this is point A. According to this rule number 6, the sum of the angles around point A equals to 360 degrees. In order to prove that this rule number 6 is true, I draw this straight line that passes through point A. Now we can implement rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the upper side of this straight line at point A, the sum of the angles must be equal to 180 degrees. But in the lower side of this straight line at point A, the sum of the angles must be also equal to 180 degrees according to the sum rule number 3. And therefore, in total, the sum of the angles in the upper side of this straight line at point A, that is 180 degrees, plus the sum of the angles in the lower side of this straight line at point A, that is also 180 degrees, in total, it is equal to 360 degrees. The sum of the angles in the upper side at point A plus the sum of the angles in the lower side of this straight line at point A is 180 degrees. So 180 degrees plus 180 degrees, it is 360 degrees. That is the sum of the angles around point A in total. Exactly like this rule number 6. We can actually implement rule number 6 in our drawing. Why? Because in our drawing, if we focus at point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees. So which angles we have around point C? We have this angle that is the right angle, is equal to 90 degrees, plus the missing angle here, in total it must be equal to 360 degrees. Therefore, this missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles around point C, according to rule number 6. Therefore, the missing angle equals to 270 degrees in its size, and this missing angle is in the center angle QCB. So the center angle QCB equals to 270 degrees. Therefore, the peripheral angle QSB must be equal to 270 degrees over 2, that is 135 degrees, according to rule number 13. In the next step, we'll focus on triangle BSQ. Triangle BSQ, side BS equals to side SQ. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two sides that are located in front of those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha, according to the rule that I mentioned. And you also note that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in the isosceles triangle, triangle BSQ. Which angles we have in the isosceles triangle BSQ? We have alpha plus alpha is 2 alpha, plus this angle that is 135 degrees. In total, the sum of those three angles must be equal to 180 degrees. Here we subtract 135 degrees from this equation, and we get that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. 2 alpha equals to 45 degrees. We divide this equation by 2, and finally we get that alpha equals to 45 over 2 degrees. So here, this is angle alpha that is equal to 45 over 2 degrees. And this is also angle alpha that is equal to 45 over 2 degrees. In the next step, I'll copy the right triangle, triangle PBQ in the new page, and we'll analyze this right triangle, triangle PBQ. Side PB of this right triangle PBQ equals to the square root of 2 units in its length. Side BQ of this right triangle equals to square root of 2 times x units, according to what we already found out in the beginning of the lecture. And this is angle alpha, again here, angle SQB, this is again SQB, is equal to alpha, and alpha equals to 45 over 2 degrees. This is angle SQB that is equal to 45 over 2 degrees. So this angle equals to 45 over 2 degrees. So this is the right triangle, triangle PQB that I copied from the original drawing. In this right triangle PQB, tangents 45 over 2 degrees equals to PB over BQ. PB is square root of 2 and BQ is square root of 2 times x. So we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled and we left only with 1 over x. In conclusion, we found out that according to equation number 1, tangents 45 over 2 degrees equals to 1 over x. And we have the trigonometric identity, the tangents to theta equals to 2 times tangents theta over 1 minus tangents square theta. In the next step, we'll define theta as 45 over 2 degrees. So if theta is 45 over 2 degrees, it means that 2 theta is 45 degrees. Now we'll substitute theta in this trigonometric identity by 45 over 2 degrees, and we substitute 2 theta by 45 degrees. This will be equation number 2, and we get that according to equation number 2 we have here tangents 2 theta, and 2 theta is 45 degrees according to our definition, and it is equals to 2 times tangents theta, and theta is 45 over 2 degrees according to our definition, divided by 1 minus tangents square theta, and theta is 45 over 2 degrees according to our definition. In conclusion, we found out that according to equation number 1, according to equation number 2, tangents 45 degrees equals to 2 times tangents 45 over 2 degrees over 1 minus tangent square 45 over 2 degrees. In the next step, we will define tangents 45 over 2 degrees as t, and we'll substitute tangents 45 over 2 degrees in this equation, equation number 2 by t. And we get that according to this equation, equation number 2, we have here tangents 45 degrees is 1, and it is equals to 2 times tangents 45 degrees over 2. Tangents 45 degrees over 2 according to our definition is t. So in the numerator we have 2t over 1 minus tangent square 45 over 2 degrees. If tangent 45 over 2 degrees is t, then tangent square 45 over 2 degrees will be equal to t squared. So in total, in the denominator we have 1 minus t squared. In conclusion, found out that according to equation number 2, 1 equals to 2t minus 1 equals to 2t over 1 minus t squared. Here we multiply this equation, equation number 2 by 1 minus t squared, and we get that according to this equation, equation number 2, 1 minus t squared equals to 2t. Here we add to this equation, equation number 2t squared, and we get that according to equation number 2, t squared plus 2t equals to 1. Here we subtract 1 from this equation, equation number 2, and finally we get that t squared plus 2t minus 1 equals to 0. So actually this is a quadratic equation, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the variable that we are looking for is t, so x equals to t. The coefficient a equals to 1. The coefficient b equals to t. The coefficient b equals to 2 here. And the coefficient c equals to minus 1. Now we put the data inside this formula for x, and we find out the value of the values of t, because x equals to t. So x equals to t, therefore we substitute x by t, and we get that t equals to minus b. b is 2, therefore minus b is minus 2, plus minus square root of b squared. b is 2, so b squared is 2 squared, that is 4, minus 4 times a is 1, times c, that is minus 1. All divided by 2 times a. a is 1, so it is 2 times 1. So here t equals to minus 2 plus minus. Inside the root we have minus 4 times minus 1 is plus 4, and 4 plus 4 is 8. So in total, inside the root we left only with 8 divided by 2. So here t equals to minus 2 plus minus square root of 8. And 8 is 4 times 2, so we substitute 8 by 4 times 2 over 2. So t equals to minus 2 plus minus, the square root of 4 is 2, so inside the root we left only with 2 over 2. So t equals to minus 2 plus minus 2 times square root of 2 times, t equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so in total this expression equals to the square root of 2. In conclusion, we found out that t equals to minus 1 plus minus square root of 2. So here we will have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution for t is that t equals to minus 1 plus square root of 2. Repeat again. We have here two solutions that are possible for t. according to the first solution, t equals to minus 1 minus square root of 2, and according to the second solution for t, t equals to minus 1 plus square root of 2. So according to the first solution for t equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number, therefore t is a negative number. But we have, according to our definition, tangents 45 over 2 degrees equals to t. But tangents 45 over 2 degrees, it is a positive number, so t is a positive number. So t cannot be simultaneously a positive number and a negative number. Therefore, this solution is the correct solution. We cancel this solution, and we left only with the second solution that is possible for t, that t equals to minus 1 plus square root of 2. Or t equals to the square root of 2 minus 1. We just change the orders of the numbers. A plus b equals to b plus a. So t equals to the square root of 2 minus 1, but according to our definition, t equals to tangents 45 over 2 degrees. So from one side, tangents t equals to tangents 45 over 2 degrees, but from the other side, t also equals to the square root of 2 minus 1. So in conclusion, we found out that according to equation number 2, tangents 45 over 2 degrees equals to the square root of 2 minus 1. From one side, but from the other side, we have already found out that tangents 45 over 2 degrees equals to 1 over x. Here we have in page number 4, we already found out that tangents 45 over 2 degrees equals to 1 over x according to equation number 1. So we actually have two different equations for tangents 45 over 2 degrees. Therefore, we'll create equation number 3. According to equation number 3, tangents 45 over 2 degrees according to equation number 1 must be equal to tangents 45 over 2 degrees according to equation number 2. Okay, so tangents 45 over 2 degrees according to equation number 1 is 1 over x, and it must be equal to tangents 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. So in conclusion, we found out that according to equation number 3, 1 over x equals to the square root of 2 minus 1. Here we will multiply this equation number 3 by x, and we get that according to equation number 3, 1 equals to x times square root of 2 minus 1. Here we will divide this equation number 3 by square root of 2 minus 1. And we get that x equals to 1 over square root of 2 minus 1. So actually we found out that x equals to 1 over square root of 2 minus 1. Okay. Now we will multiply this side of the equation by square root of 2 plus 1, and then we will divide it by square root of 2 plus 1. Square root of 2 plus 1 over square root of 2 plus 1 is 1. And it is allowable to multiply anything by 1. When you multiply by 1 some expression, you will not change the value of the expression. So this operation is allowable. So if I found out that x equals to, in the numerator we have square root of 2 plus 1 over, in the denominator we have square root of 2 minus 1 times square root of 2 plus 1. So here, what is the value of this expression? We have a algebraic identity that a minus b times a plus b equals to a squared minus b squared. According to this algebraic identity, we get that the value of this expression will be equal to square root of 2 squared, that is 2, minus 1 square, that is 1, so it is minus 1. So in total, this expression equals to 2 minus 1, that is 1. So actually found out that x equals to the square root of 2 plus 1 over this expression equals to 1. 2 minus 1 is 1. So this expression, according to this algebraic identity, equals to 2 minus 1, that is 1. So we substitute this expression by 1. That is to say, x equals to the square root of 2 plus 1 over 1. That is actually square root of 2 plus 1. So in conclusion, we found out that x equals to either square root of 2 plus 1 units, or in terms of numbers, x equals to 2.414 units. Okay, that is the answer to our question. Repeat again, x bc is equal to x equals to either square root of 2 plus 1 units in itself, or bc is equal to x. In terms of numbers, it is equal to 2.414 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment BC that is equal to x. In the domain, we have two quarter circles. Those two quarter circles touch each other at point B. In addition, we know that line segment AB equals to 1 unit in length. QS equals to SP. Again, our mission is to find out the length of this line segment BC. It is equal to x. So first of all, this is a quarter circle, and therefore side AB equals to side AP. They are both the radii of this quarter circle, therefore they are equal to each other. But AB equals to 1, therefore AP must be also equal to 1. Again, AP also equals to 1. Likewise, this is a quarter circle. This is a quarter circle, and in this quarter circle, side QC equals to side CB. But CB equals to x, therefore QC must be also equal to x. Then join points P and B together by side line, and points Q and B together by side line. So here we created the right triangle PAB. So copy the right triangle PAB in the new page and implemented the Pythagoras theorem in this right triangle PAB. This is the right triangle PAB that I copied from the original drawing. According to the Pythagoras theorem in this right triangle PAB, PB squared equals to PA squared plus AB squared. So PB squared, that is the square of the hypotenuse, equals to PA squared. PA is 1, therefore PA squared is 1 squared, that is 1, plus AB squared. AB is 1, therefore AB squared is 1, so in total PB squared equals to 1 plus 1, that is 2. So PB squared equals to 2, we took a root out of this equation and finally found out that PB equals to the square root of 2. Here, the length of the hypotenuse PB of the right triangle PAB is equals to square root of 2 units. Likewise, I copied the right triangle QBC in a new page and recorded the Pythagoras theorem, this right triangle QBC. This is the right triangle QBC that I copied from the original domain. According to the Pythagoras theorem, this right triangle QBC, QB squared equals to QC squared plus CB squared. So QB squared, that is the square of the hypotenuse, equals to QC squared. QC is x, therefore QC squared is x squared, plus BC squared. BC is x, therefore BC squared is x squared. So in total, QB squared equals to x squared plus x squared, that is 2x squared. QB squared equals to 2x squared. We took root out of this equation and finally found out that QB equals to the square root of 2 times x squared. That is to say, QB equals to the square root of 2 times the square root of x squared. The square root of x squared is x. So in total, QB equals to the square root of 2 times x. Here, the hypotenuse QB of this right triangle QBC equals to the square root of 2 times x units. Then we have, we know that PA in the right triangle PAB, PA equals to AB. This is a right triangle that is also a isosceles triangle. And we have the rule that in front of equal sides there are equal angles in a triangle. So if in front of those two equal sides we have those two angles that are also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha because they are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So in the right triangle PAB, alpha plus alpha is 2 alpha plus 90 degrees, it is 180 degrees. Again, 2 alpha plus 90 degrees is 180 degrees. We subtracted 90 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 90 degrees, it is 90 degrees. 2 alpha equals to 90 degrees. We divided this equation by 2 and finally found out that alpha equals to 45 degrees. So this is angle alpha that equals to 45 degrees. And this is also angle alpha that is equal to 45 degrees. If we repeat on the same process in this right triangle, we will arrive to the conclusion that those two angles, each of them is equal to 45 degrees. Then I presented to you rule number 3 and implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have in the drawing this straight line AB. So if we focus on the upper side of this straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha plus this angle that is beta, so alpha plus beta must be equal to 180 degrees according to this rule number 3. We actually can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the upper side of this straight line AC, if we focus on the upper side of the straight line AC at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I copied the straight line AC in the new page and we implemented the rule number 3 in the straight line AC. Okay, so here we have so this is the straight line AC that I copied from the original drawing. This is point B. So the sum of the angles on the upper side of this straight line AC at point B must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of AC at point B? We have this angle that is 45 degrees plus the missing angle that is X plus this angle that is 45 degrees. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So 45 degrees plus 45 degrees is 90 degrees. So in total, this side of the equation we have 90 degrees plus X. Is equals to 180 degrees. We subtracted 90 degrees from this equation and finally found out that X equals to 180 degrees minus 90 degrees, it is 90 degrees. So the missing angle here is the right angle, it is equal to 90 degrees. So you can write down here in the original drawing that this is the right angle, this is equal to 90 degrees. Then I copied the right angle PBQ in a new page and we block this right angle by a circle. We have the rule that any triangle can be blocked by a circle. This is the right angle PBQ that I copied from the original drawing and we blocked this right angle triangle PBQ by this circle. So in the drawing we have peripheral angle PBQ. This peripheral angle PBQ is equals to 90 degrees in size and we have peripheral angle PBQ equals to 90 degrees and we have rule number 5 that relates to any peripheral angle that is the right angle. According to rule number 5, any peripheral angle that is equal to 90 degrees must be subtended on the diameter of the circle. So in the drawing we have a circle, inside the circle we have peripheral angle MAM. This peripheral angle, it is a right angle, it is equal to 90 degrees in size. Therefore, this peripheral angle MAN is subtended on the diameter of the circle. MN is the diameter of the circle. Why chord MN is the diameter of the circle? Because of the fact that chord MN passes point O, that is the center of the circle, and we know that any chord that passes from the center of the circle must be the diameter of the circle. So, in conclusion, you can say that peripheral angle MAN, that is the right angle, is subtended on the diameter of the circle. You can implement rule number 5 in our drawing. Why? Because in our drawing we have this is peripheral angle PBQ, that is the right angle, therefore peripheral angle PBQ must be subtended on the diameter of the circle. So according to rule number 5, PQ is the diameter of the circle. If we define the radius of this circle as R, then the diameter PQ must be equal to 2R from one side. But from the other side, we know that PS equals to SQ according to what is given in the question. So if PS is X, then SQ must be also equal to X because they are equal to each other. So in total PQ equals to PS plus SQ. That is to say PQ equals to PS, that is X, plus XQ, that is also X. So in total PQ equals to X plus X, that is 2X. So from one side PQ equals to 2X, from the other side PQ is the diameter of this circle, that is to say it is equals to 2R. From those two equations, PQ equals to 2R and PQ equals to 2X, we will derive that 2R equals to 2X. Here we divided this equation by 2 and finally found out that R equals to X. So here X equals to R, and here also, that is to say SP equals to R, and here also X equals to R, that is to say QS equals to R. Then I copied point S from this original drawing. Point S is located on PQ. So I copied point S from this original drawing to our new drawing. Exactly the same location that is located here, I copied it here in the new drawing. This is point S that I copied from the original drawing to this new drawing. So we just right now found out that PS equals to R and SQ equals to R. So those two radii touch each other at point S, therefore point S must be the center of this circle. Okay, point S is the center of the circle. Then adjoin points S and B together by a straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of this circle, it is equal to R. In conclusion, found out that QS equals to SP equals to SB, they are all the radii of this circle, therefore they are equal to each other. Here, adjoin points S and B together by a straight line. SB is the radius of this circle, of the radius of the spiral circle. Again, SQ equals to SB equals to SP equals to R. Then we did the construction, that is to say, first of all, I copied the big quarter circle to a new page, and then we completed this quarter circle to a circle. This is the quarter circle that I copied from the original domain. Here SQ equals to SB equals to R. They are both the radii of the previous circle, therefore they are equal to each other. So this is the quarter circle. This angle equals to 90 degrees because it is a quarter circle. Then I completed this quarter circle to a circle. And then I presented to you a new rule and we implemented the new rule in our drawing. According to the new rule, rule number 13, the central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have this circle, inside this circle we have the peripheral angle ACB. This peripheral angle ACB equals to theta in its size, and it is subtended on arc AB. In addition, we have in this drawing the central angle AOB. This is also subtended on arc AB, and therefore the central angle must be twice as large as the peripheral angle that is subtended on the same arc, because of the fact that the peripheral angle, this peripheral angle AOB, and the central angle AOB is subtended on the same arc as this peripheral angle ACB. Therefore, the central angle will be twice as large as the peripheral angle ACB. Peripheral angle ACB equals to theta, therefore the central angle AOB that is subtended on the same arc AB will be equal to theta. We can implement rule number 13 in our drawing. Why? Because in our drawing we have this is peripheral angle BSQ. This peripheral angle BSQ is subtended on arc QB. And we have also the central angle QCB. This is the central angle QCB that is subtended on the same arc QB. Therefore, the central angle QCB must be twice as large as this peripheral angle QSB that is subtended on the same arc QB. Now we must find out what is the size of the central angle, and then the size of the central angle over 2 will be equal to the size of this peripheral angle according to rule number 13. We found out the size of this central angle QCB according to rule number 6. According to rule number 6, the sum of the angles around the point will always add up to 360 degrees. So we have here in the drawing point A. According to this rule number 6, the sum of the angles around point A is equal to 360 degrees. In order to prove that this rule is true, I draw here a straight line that passes through point A. Now we can implement here rule number 3. According to rule number 3, the sum of the angles on the upper side of this straight line at point A equals to 90 degrees, and also the sum of the angles in the lower side of this straight line at point A must be also equal to 180 degrees. And therefore in total the sum of the angles around point A will be equal to 180 degrees plus 180 degrees, that is 360 degrees, exactly according to this rule number 6. You can actually implement rule number 6 in our drawing. Why? Because in our drawing, if you focus at each point C, the sum of the angles around point C must be equal to 360 degrees according to rule number 6. So which angles we have around point C? We have this angle that is right angle plus the missing angle. In total they must be equal to 360 degrees according to rule number 6. Therefore the missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees equals to 360 degrees. That is the sum of the angles around any point, especially around point C. So the center angle QCB equals to 270 degrees in its size. Therefore, the peripheral angle BSQ that is subtended on the same arc of QB must be equal to 270 degrees over 2, that is 135 degrees. So angle QSB equals to 135 degrees in its size. And we only found out that SQ equals to SB. So in the associated triangle QSB, in front of those two equal sides, we have those two angles that must be also equal to each other, because in front of equal sides we have equal angles in any triangle. So those two angles must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. In the right triangle, in the associated triangle QSB, the sum of the angles must be equal to 180 degrees. So which angles we have inside the associated triangle QSB? We have this angle alpha plus alpha, that is 2 alpha plus 135 degrees. In total, they must be equal to 180 degrees according to the rule that I mentioned. We subtracted 135 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees, so 2 alpha equals to 45 degrees. We divided this equation by 2 and finally found out that alpha equals to 45 over 2 degrees. This is again alpha that is equals to 45 over 2 degrees, and this is also again alpha that is equals to 45 over 2 degrees. Then I copied the right triangle PBQ in a new page and analyze this right triangle PBQ. Side PB of the right triangle PBQ is square root of 2, side BQ equals to square root of 2 times x units, and this is again alpha that is equal to 45 over 2 degrees. Because again, this is the right triangle PBQ that I copied from the original domain. PB equals to the square root of 2, BQ equals to the square root of 2 times x, and this is angle alpha that is equal to 45 over 2 degrees. In this right triangle PBQ, times 45 over 2 degrees equals to PB over BQ. That is to say, it is equals to PB that is square root of 2 over BQ that is square root of 2 times x. We have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we have to only with 1 over x. So in conclusion, found out that according to equation number 1, times 45 over 2 degrees equals to 1 over x. Yeah. Times 45 over 2 degrees equals to 1 over x. And we have the trigonometric identity that tangent 2 alpha equals to 2 tangent alpha over 1 minus tangent square. Again, tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. Here we define theta as 45 over 2 degrees. If theta is 45 over 2 degrees, it means that 2 theta is 45 degrees. Then we substituted theta in this trigonometric identity by 45 over 2 degrees, and we substituted 2 theta by 45 degrees, and we found out that tangent 2 theta, so it is tangent 2 theta, and theta, then tangent 2 theta, 2 theta is 45 degrees according to our definition. That equals to 2 tangent theta, and theta is 45 over 2 degrees according to our definition, over 1 minus tangent square theta. Tangent, so it is 1 minus tangent square theta, and theta is 45 over 2 degrees. So we found out that according to equation number 2, tangent 45 degrees equals to 2 times tangent 45 over 2 degrees over 1 minus tangent square 45 over 2 degrees. Then we define tangent 45 over 2 degrees as t, and we substitute tangent 45 over 2 degrees in this equation number 2 by t. So here tangent 45 degrees is 1, and it is equals to 2 times tangent 45 over 2 degrees is 2, so it is 2t over 1 minus tangent square 45 over 2 degrees. If tangent 45 over 2 degrees is t, it means that tangent square 45 over 2 degrees will be equal to t squared. So in conclusion, we found out that according to equation number 2, 1 equals to 2t over 1 minus t squared. We multiply this equation, equation number 2, by 1 minus t squared, and found out that 1 minus t squared equals to 2t. We added to this equation, equation number 2t squared, and found out that t squared plus 2t equals to 1. We subtracted 1 from this equation, equation number 2, and finally found out that t squared plus 2t minus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to 1 b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the variable that we are looking for here, t squared plus 2t plus minus 1 equals to 0. The variable that we are looking for is t. The coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. Here. Now we put the data inside the formula for x and found out the value or the values of t because x equals to t. So x equals to 2, so substitute x by t. So t equals to minus b. b is 2, therefore minus b is minus 2 plus minus square root of b squared. b is 2, so b squared is 2 squared, that is 4. Minus 4 times a is 1. Times c, that is minus 1 over 2a. a is 1, so it is 2 times 1. So inside the root we have minus 4 times minus 1 is plus 4, and 4 plus 4 is 8. So in total, inside the root we have 8. So t equals to minus 2 plus minus square root of 8 over 2. 8 is 4 times 2. We substitute 8 by 4 times 2. T equals to minus 2 plus minus square root of 4 times 2 over 2. The square root of 4 is 2, so inside the root we left only with 2. So in conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1 plus minus 2 over 2 is 1. So this expression in total equals to the square root of 2. In conclusion, we found out that t equals to minus 1 plus minus square root of 2. So here we will have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2, and the second solution for t is that t equals to minus 1 plus square root of 2. So according to the first solution for t, t equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number, that is to say t is a negative number from one side, but from the other side, according to our definition, t equals to times 45 over 2 degrees, that is a positive number. So t cannot be simultaneously a positive number and a negative number. Therefore, we have a contradiction here. So this solution is incorrect solution, we cancel the solution, and we left only with the second solution that is possible for t, that t equals to minus 1 plus square root of 2. From one side, but from the other side, according to our definition, t equals to times 45 over 2 degrees. So t from one side equals to times 45 over 2 degrees, but from the other side, according to the second solution, t equals to the square root of 2 minus 1. So here, this equation number 2 means that t equals to t. So according to the second solution, to equation number 2, times 45 over 2 degrees equals to the square root of 2 minus 1. This is according to equation number 2, but according to equation number 1, we have already found out that times 45 over 2 degrees times 45 over 2 degrees equals to 1 over x. Here times 45 over 2. According to equation number 1, we have already found out that times 45 over 2 degrees equals to 1 over x. So we have two different equations for times 45 over 2 degrees. Therefore, we created equation number 3 that states that times 45 over 2 degrees according to equation number 1 must be equal to tan is 45 over 2 degrees according to equation number 2. Tan is 45 over 2 degrees according to equation number 1 is 1 over x. And it must be equal to tan is 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. So in conclusion, found out that according to equation number 3, 1 over x equals to the square root of 2 minus 1. Here we multiply this equation number 3 by x, and found out that 1 equals to x times square root of 2 minus 1. Here we divided this equation number 3 by square root of 2 minus 1, and found out that according to equation number 3, x equals to 1 over square root of 2 minus 1. So x equals to 1 minus square root of 2 minus 1. X equals to 1 over square root of 2 minus 1. Then we multiply this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1. Square root of 2 plus 1 over square root of 2 plus 1 is 1. And it is allowable to multiply anything by 1. You don't change the value of the expression when you multiply it by 1. So this operation is allowable. So in conclusion, found out that in the numerator we have here square root of x equals to the square root of 2 plus 1 over this expression square root of 2 minus 1 times square root of 2 plus 1 equals to, according to this algebraic identity, that a minus b times a plus b equals to a squared minus b squared. This expression will be equal to the square root of 2 squared, that is 2, minus 1 squared, that is 1. So in total this expression equals to 2 minus 1, that is 1. So this expression in total equals to 1. Therefore x equals to the square root of 2 plus 1, and this expression in total equals to 1 over 1. And square root of 2 plus 1 over 1 is square root of 2 plus 1. So in total, we actually found out in conclusion that x equals to either square root of 2 plus 1 units, or in terms of numbers, x equals to 2.414 units. I repeat again, the length of this line segment BC that's equal to x, it is equals to either square root of 2 plus 1 units, or in terms of numbers, BC that is equal to x equals to 2.414 units. Okay, thank you very much.